Before we move on to regulation of the glomerular filtration rate, I think it's important that you understand this relationship. The blood pressure in the glomerulus, which is the same thing as the net filtration pressure, controls the glomerular filtration rate, or how many mils are being filtered per minute. We want to maintain a glomerular filtration rate of about 125 mils per minute. We regulate that by regulating the blood pressure in the glomerulus. If the blood pressure in the glomerulus goes up, glomerular filtration rate increases. If the blood pressure in the glomerulus goes down, glomerular filtration rate will decrease. You can regulate the glomerular filtration rate by regulating your blood pressure in the glomerulus. So what determines blood pressure? It is the amount of blood in the vessel pushing up against the walls of the vessel. If I want to regulate glomerular blood pressure, then I need to regulate how much blood flows into the glomerulus. To decrease blood pressure in the glomerulus, I have got to decrease blood flow into the glomerulus, and I can do that by vasoconstriction of the afferent arterioles. If I want to increase blood pressure in the glomerulus, I have got to allow more blood to flow into the glomerulus, and this can occur by vasodilation of the afferent arterioles. So keep these in mind as we move on to the regulation of glomerular filtration. Let's look at how your body regulates the glomerular filtration rate, or GFR. There are two ways that your body can regulate the GFR: through intrinsic controls and through extrinsic controls. We're going to start with the intrinsic controls. This involves the kidneys regulating the GFR without external input from the nervous system or hormones. Because the kidneys are regulating the GFR themselves, this is renal autoregulation. There are two ways that renal autoregulation can occur. The first involves the JG complex through a process called tubular glomerular feedback. Chemoreceptors within the JG complex, called macula densa cells, monitor the sodium chloride in the filtrate. Elevated levels of sodium chloride in the filtrate reflect an increase in the glomerular filtration rate. If the glomerular filtration rate is increased, the macula densa cells, in response to the elevated sodium chloride levels, will release chemical messengers that will go to the afferent arterioles. In response to the chemical messengers, the afferent arterioles will contract, bringing about vasoconstriction. This will decrease blood flow into the glomerulus, allowing that blood pressure in the glomerulus to drop, returning the glomerular filtration rate back to normal. A second form of autoregulation is myogenic mechanisms. When the blood pressure in the afferent arterioles is elevated, this stretches the walls of the afferent arteriole more so. When the smooth muscles in the afferent arterioles are stretched, they contract. This brings about vasoconstriction of the afferent arterioles in response to elevated blood pressure within them. When they contract, this decreases blood flow into the glomerulus, preventing an increase in the glomerular filtration rate, maintaining it within the normal range.